In this lesson, we are going to cover angles in standard position. So by doing that, we put an angle in the xy coordinate system. Then we could extend the angles from 0 to 360 degrees to any angles, negative infinity to positive infinity. So the definition for angles in standard position is the vertex of the angles is always at the origin 0, 0, and the initial arm is always on the positive x-axis. So this is a 0, 0 point, and the initial arm is on the positive x-axis. And in order to describe the angles, we are going to introduce the positive and the negative angles. The positive angles is counterclockwise. And the negative is opposite, is clockwise. And also we want to introduce a principal angle because there are so many angles have the same terminal arm. So for this angle, we could continue to rotate. Then you will have another angle that is plus 360 degrees, have the same terminal arm. So we want to introduce the principal angle. Then you will have only one angle corresponding to the terminal arm for the principal angle. Principal angle is the angle between 0 degrees and 360 degrees. So it means from the initial arm, we turn counterclockwise. The first time it reaches the terminal arm, we call that principal angle. And the related acute angle is angle between 0 and 90 degrees. So this one is formed by the terminal arm with a close by x-axis. The close by. So for this one, the close by is positive x-axis. If we have another one, the terminal arm is here, then the related acute angle will be here, the close by x-axis. So now we are going to see, based on the definition of these terms, how to find the related acute angle. Reference angle is same as a related acute angle, and one coterminal angle, which means have the same terminal arm, but could be other angles, plus 360, minus 360, or continue 360 times 2, you will have the coterminal arms, coterminal angles. So this is x, positive x-axis, this is positive y-axis, and this is 360 degrees. So the related acute angle is the definition of this terminal arm with a close by x-axis. This will give you the angle that is less than 90 degrees. So from here, we are going to see this is 90 degrees minus 630. You will have 60 degrees as a related acute angle. So we could write related acute angle equals 90 take away 30 degrees is formed with a close by x-axis, and the reference angle is same. It's just different name for the related acute angle. And one coterminal angle, we could find the principal angle that is from the initial arm, the positive x-axis, turn clockwise, first time you reach the terminal arm, that is a PA, principal angle. And this one will be 180 plus 60 degrees. So it's 240 degrees. And the co-terminal arm, to co-terminal angle, we could do it from here. We pass this one, continue rotate, then come back and reach this terminal arm again, so it will be 240 plus 360. So co-terminal. Angle equals 240 plus 360 degrees, or you could plus 360 times 270, 720 degrees. You will have the co-terminal arm again, so this one will be 500 degrees. So that is for these co-terminal arms. As we put this angle in standard position in XY coordinate system, and it will be easier for us to connect the angle with a point in the XY coordinate system. So we have a point that is -3, -6. And the angle, this is a terminal arm, so it will pass this point. So the -3, -6. And we are going to see how we can connect the point with the primary trig ratios. So connect to sine, cosine, and tangent. So from this point, we want to create a right angle. And always remember, we are going to create a right angle with the x-axis. So we draw a perpendicular line to the x-axis, then we have 90 degrees, we have this right angle triangle. And in this right angle triangle, we know that this side is corresponding to the x coordinate and the vertical corresponding to y coordinate. And the distance from this origin to this point, we use r to represent. Then in this triangle, we could write it as x equals -3, y equals -6, and r is distance between the origin to this point. We could use a Pythagorean theorem, a squared plus c squared equal x squared plus b squared equals c squared. So it's just r squared equals x squared plus y squared. We sub in, then we have -3 squared plus -6 squared. Then we do the calculation, you will have square root 45. So in this right angle triangle, and the mathematician expand the SOHCAHTOA, the sine, cosine, tangent, to XYR. So this one, based on this related acute angle, the y is opposite in this triangle, and x is adjacent, and r is hypotenuse. We know the definition for this, so we use theta to represent this principal angle, this angle, with the same terminal arm. It doesn't matter what this angle is, principal angle or co-terminal angles, as long as the terminal arms are same, then the sine, cosine, tangent will be same. You will create the same right angle triangle here. So the mathematician extend the definition for sine angle theta in this right angle triangle opposite over hypotenuse to include the xy positive negative. So it's y over r. It will give you negative 6 over square root 45. So this is how the mathematician extends from a sine, cosine, tangent in a triangle to any angles by putting this angle in standard position. And cosine theta is adjacent over hypotenuse. Extended to this xy coordinate, it will be just x over r. And you have negative x 3 over square root 45 and the tangent equals y opposite over adjacent equals y over x equals negative 6 over negative 3 give you positive 2. So this is how the mathematicians extend the angles from a triangle to any angles by introduce angle in standard position and by using a point on the terminal arm to get the sine, cosine, tangent for the trig ratios for this angle theta. And exact values means we are not going to round it, so you could keep it in the fraction form. And also if we want to rationalize the denominator, we could times the square root 45 to both numerator and denominator. So we don't want to see the square root under the denominator, so we could times, if it's monomial, we times the same thing, then you will have positive. So negative 6 square root 45, actually we could change it to 3 square root 5. Then we simplify it, you will have negative 2 over 5 square root 5. So this one we could simplify it first. Square root 45 is 9 times 5. We take the 9 out, is square root 9 is 3, then square root 5. Then we rationalize the denominator by times the square root 5, the monomial, just times the radical number by itself, then you will have the squared. So the 3 cancel out, we have negative square root 5 over 5. So this is called simple list form. And question B, it asks you to find this principal angle. So the principal angle, we are going to find it by doing we could use a tangent theta. We find the RA first, related acute angle. The reason for that, if we do the other angles, some calculator will give you different answers. We find RA, then from RA is always, we know is from 180 plus RA, we get this number. So we could use a tangent theta to find RA, so we use only the positive ratios to find RA, because RA is from 0 to 90 degrees. That is same as what we did before in a triangle. So tangent inverse, in order to find RA, we do the inverse. Then use your calculator, you will find out RA equals 63.44. Then the principal angle is from the positive axis counterclockwise rotate. First time you reach the terminal arm, that is a principal angle, so it's 180 plus RA. Then we have 243.44 degrees. And later we are going to discuss more about how to solve a trig equation. From a last example, we have seen that sine, cosine, tangent, they could be negative, and in order to solve a trig equation, we need to know in which quadrant the sine, cosine could be negative or positive. Then from there, we could decide the solution for the trig equation. So based on the definition for sine, cosine, tangent equals xy coordinate and the distance from that point to the origin, we could determine the positive or negative for each ratio in each quadrant. So we start from this one is first quadrant, then counterclockwise, second quadrant, third quadrant, and the fourth quadrant. So in the first quadrant, we know that both x and y coordinate, they are positive. So the point in the first quadrant is both positive. And for the r is always positive. So now we are going to see the division. If same sign divide, you are going to have positive. And r always positive, so we just need to see that y is positive or negative to determine the sine theta is positive or negative. So r is positive. So we are going to see in first quadrant both x, y positive. So it means y positive divided by positive, y over r, both positive, give you positive. And x over r, x coordinate positive, r is positive, so give you positive. And the tangent theta is y over x, both y and x positive, give you positive. That is same as what we did before in a right angle triangle. The sine, cosine, tangent equals opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, always positive. So in first quadrant, all the theta is less than 90 degrees. And for the second quadrant, we know that x is negative, but y is positive. So y is positive for sine, y over r, both positive. And for the cosine, x is negative, negative divided by r, positive, give you negative. And for the tangent, y is positive, x is negative, so different sign give you negative. And you will see now, if we extend the angle from 0 to 90 degrees to 90 to 180 degrees, you will have cosine and tangent negative. Then we are going to see the third quadrant. Third quadrant, x is negative, y is negative, so both negative. So y over r, negative divided by r, always positive, is negative. X is negative, r is positive, give you negative. Y over x, both x, y coordinate is negative. Same sign, give you positive. And for the fourth quadrant, the x is positive, y is negative coordinate. So y is negative divided by positive r, give you negative. X is negative, x is positive divided by r positive, give you positive. Y is negative, x is positive, divide, give you negative. So from this chart, we are going to circle the positive. Then in future, we just remember in which quadrant the ratio is positive, then we are able to tell. If a ratio is given, we are able to tell the angle may be in which quadrant. So for the first quadrant, you will see is 0 to 90 degrees. It's in a right angle triangle. Always the sine, cosine, tangent positive. So we use the first, this one, all trig ratios positive, so we use A all. And the second quadrant is sine only positive. The third quadrant only tangent positive. And in the last fourth quadrant only cosine to be positive. So we use the first letter A, S, T, C. So you could remember it with all students take calculus. Or you could create another sentence to remember this. So A is in the first quadrant, all the sine, cosine, tangent ratios are positive. And S represent in the second quadrant, only the sine ratio is positive. And the T represent in the third quadrant, only tangent ratio is positive. And the last quadrant, only cosine is positive. So now we are going to see how we can use this conclusion to solve a trig equation. So now we are going to solve a trig equation. Sine theta equals -2/3, and angle theta is between 0 to 360 degrees. So for such question, we want to solve for which quadrant it could be. So sine equals negative, we know that it's all students take calculus. First quadrant all positive, second quadrant sine is positive, and third quadrant tangent positive, and fourth quadrant only cosine positive. So sine positive, all positive, so these two quadrants couldn't be. It will be third and fourth quadrant only. And for the RA is a terminal arm formed with a x-axis close by x-axis. So we have these two RAs here. And one angle theta is this one, another one is from initial arm x all the way to this terminal arm. So this one will be 180 plus RA for theta, and this one will be 360 take away RA. So our task will be look for the RA. So this one, step 1, determine the quadrant. So this is the reason why we need to find which quadrant the sine, cosine, tangent could be positive. Determine the quadrants. So sine is negative, then not the first one, not the second one is the quadrant third and fourth. So first one, second one, third one, and fourth. And you will see that based on the RA, in the third quadrant always 180 plus RA. In the fourth quadrant always 360 minus RA. So the second task is determine the RA, solve for RA. And we know that RA is acute angle, so it's less than 90 degrees. The sine ratio, cosine ratio, tangent ratio for RA is always positive, so we ignore the negative sign. So for RA, the ratio need to be positive, so sine inverse 2/3. Then get your calculator out, you will be able to find RA equals 41.8 degrees. Then step 3 is just write the final solutions out in quadrant third. So it's always in third quadrant, the angle equals 180 degrees principal angle equals 180 degrees plus RA. So you have 221.8 degrees. And in the fourth quadrant, the angle equals 360, take away RA. It gives you 308.2 degrees. And if you use your calculator, just do the inverse of negative directly, you will find out it may give you negative 41.8 degrees, which is not from 0 to 360 degrees. That is the reason that we want to find RA first. Then from RA, from the quadrant, you can find two angles. So try not to use a inverse of a negative angle, because it may give you all different answers, not your solutions. So that is for solving a trig equation. Then we practice more. This one is to tell you that is an angle and lies in second quadrant, and the cosine theta is negative 2/3. So in the second quadrant, then cosine is negative. So it asks you to determine the exact value of x, y, r. So this one, it's asking you for a point on the terminal arm. Then we know that this is x, this is y, this is r, and cosine equals adjacent or hypotenuse x over r equals negative 2/3. You could have infinite numbers of points on this terminal arm, but we want to find the simplest one. We are going to let x equals negative 2, r equals 3. Then the y is a b value, so x squared plus y squared equals r squared. Then we solve for y. We ask the y, move the negative 2 squared to other side is minus 4. So we have y equals square root, positive or negative. 9 minus 4 give you 5. And because in the second quadrant, so it will be positive 5. This is quadrant second. If it's a third quadrant, then y will be negative. So by using the definition for the cosine using the point, then we have the x equals negative 2, y equals square root 5, r equals 3. This is 1 point on this terminal arm. Then it asks you to sketch this angle in standard position, which graph it here already. Vertex at 0, 0. This point is -2 and square root 5. So question 3 asks you to find the principal angle theta. In order to find the principal angle theta, we are going to solve this quadratic, the trig equation, and we want to find the RA. This time we didn't determine the quadrant because it's set in second quadrant already. So determine RA will be positive ratio only because RA is less than 90 degrees. So do the inverse of cosine. We have cosine inverse 2/3. Then use your calculator, you will find out it's 48.2 degrees. So in the second quadrant, you will see is 180 take away RA. So this works all the time. In second quadrant, angle is 180 minus RA. You will have 131.8 degrees. And it to the nearest degree is 132 degrees. And the beta is acute angle is 48 degrees. Then it's done for this question. So in order to solve a trig equation, we do the quadrant first, then solve for RA, then based on the quadrant, second quadrant 180 minus RA, first quadrant will be same, equals RA. The third quadrant is 180 plus RA for the principal angle, and the fourth quadrant is 360 take away RA. Okay, so that is all for today's this lesson, and in this lesson we covered the definition of principal angle from 0 to 360 degrees. Related acute angle is from 0 to 90 degrees. The terminal arms formed with a close by x-axis. And the positive angle from positive x-axis counterclockwise, negative angle from positive x-axis clockwise. And also we have covered the co-terminal arm. As long as they have the same terminal arm, we call the angles co-terminal angles. So it will be this angle plus 360 degrees times an integer, could be positive, could be negative. And when we are solving for an equation, trig equation, we solve for the related acute angle. Then based on the quadrant, first quadrant, RA equals angle, the principal angle. Second quadrant, principal angle equals 180 minus RA. Third quadrant is 180 plus RA. And the fourth quadrant is 360 minus RA. Thanks for watching.